All right, we are right on the edge of a massive shift in software, and it's all being driven by this idea of AI agents. So today, we're going to do a deep dive. We're going to unpack what they are, how they actually work, and why they're not just an upgrade, they're a whole new way of building and interacting with technology.
So, here's the plan. First, we'll tackle the big picture, the huge paradigm shift agents represent. Then, we'll peek under the hood and look at the agent's core operating loop. After that, we'll explore the toolkit that gives these agents their power. Then, we'll get into the different types of agents you'll see out there. And finally, we'll see how you can architect these agents into really powerful, intelligent systems.
Okay, let's kick things off with the main idea, because this is a big one. For as long as we've had computers, programming has been about giving them a super detailed, step-by-step recipe. But the agent paradigm, it just flips that completely on its head. We're moving away from giving instructions and toward just defining a high-level goal and then letting the agent figure out how to get there. It's a fundamental leap.
So what is an AI agent at its core? Well, think of it like a software assistant, but on steroids. It's a program that can actually see and understand its environment, make smart calls based on what it sees, and then, this is the key, take action to hit the goals we give it. Really, it's the difference between using a tool and having a partner.
And this slide right here just nails the difference. Traditional programs, they're like following a map where the route is already drawn for you. You have to tell it every single turn. But an AI agent, that's like telling a self-driving car your destination. You just say, take me here, and it figures out the best route. We're moving from a world of rigid instructions to one of intelligent autonomy.
So how does an agent actually figure out the how? What's going on behind the scenes that takes it from a big picture goal to a series of smart actions? To get that, we need to look under the hood at its core operational loop. An AI agent is basically living in this constant cycle. It's always monitoring its environment, grabbing new info. Then it crunches that data, reasoning about what it all means for its goals. Based on that thinking, it takes an action. It does something. And here's the magic part. It learns from the feedback of that action, which makes it smarter for the next time around. It's this endless loop: perceive, think, act, and learn. Now, this constant loop is powered by a set of foundational capabilities, which is what gives the agent its intelligence and freedom to act. So, let's open up the agent's toolkit and see what we're working with.
We're going to break down 4 key pieces that make these agents so incredibly powerful. Their ability to act on their own, their persistent memory that lets them learn, the reasoning engine that acts as their brain, usually a large language model, and of course, their ability to connect with other tools to get stuff done.
First up, autonomy. And you gotta know, this is not just a simple on or off switch. Agents work across a whole spectrum. On one end, you might have an agent that just suggests an action for a person to approve. On the other end, you can have one making and executing decisions all by itself. A huge part of building good agents is figuring out where on that spectrum it should live and building in the right guardrails to keep it safe and on track.
Next, persistent memory. And this is a total game changer. A typical API call is stateless. It has amnesia. It forgets everything the second it's done. But an agent remembers. It keeps track of conversations, it knows what it's done in the past, and it understands the current state of things. This lets it handle really complex, multi-step jobs without starting from zero every single time.
And that brings us to a super important point. It's easy to think the LLM, the large language model, is the agent. But that's not quite right. Think of it this way. The LLM is the agent's brain. It does the thinking, the reasoning, the problem solving. But the agent architecture, that's the body. It's the framework that takes the brain's ideas and turns them into actual actions in the world.
So how does it take action? This is where the rubber meets the road. Tool integration. This is what makes agents so practical. They can run code, they can call out to other APIs to get live info, they can talk to databases. By pulling all these different tools together, they can handle these incredibly complex workflows that a standalone LLM just couldn't touch. Okay, so now that we've seen what's inside the toolkit, let's look at how these parts get put together. There isn't just one type of agent. They come in all different shapes and sizes, each built for a specific kind of job.
This table gives us a great little cheat sheet. You've got your simple reflex agent, super basic, just operates on if this, then that rules. Perfect for simple things like validation checks. A step up is the model-based agent, which actually keeps track of how the world is changing. Then you have goal-based agents. These are the planners. They can map out a whole sequence of actions to hit a target.
Learning agents are really cool. They actually get better over time through trial and error. And finally, utility-based agents are the expert decision makers, able to weigh a bunch of different factors to pick the absolute best action.
Okay, so we've got all these different types of agents with their own unique skills. But how do we actually put them to work to solve real problems? For our last section, let's look at how these agents are architected into complete intelligent systems. The most straightforward way is the single agent architecture. This is where you have one agent doing one specific job, like a personal assistant or a specialized service. Think of a bot that can book all your meetings or one that does nothing but summarize research papers for you. It's perfect for focused tasks that don't need a ton of coordination.
But for the really big, messy problems, one agent isn't going to cut it. That's when you bring in a team. In a multiple agent architecture, you might have specialized agents working together, one to do research, another to create a plan, and a third to actually execute that plan. They all coordinate to solve problems that would be way too much for any single agent to handle alone.
But honestly, the most powerful approach, and the most practical one right now, is all about collaboration between humans and machines. The point isn't to replace people. It's about creating a true partnership where the agents handle the grunt work, the analysis, the routine tasks, which frees up us humans to focus on what we do best, making the final call, thinking creatively, and setting the direction. The real goal here is augmentation, making us better.
So by moving away from this world of rigid step-by-step instructions to one of intelligent, high-level objectives, AI agents are really set to completely reshape how software works. They give us this powerful new way to reason, to learn, and to adapt, and they have the potential to just massively accelerate everything we do. So as this tech becomes more and more common, I'll just leave you with this question: what is the first big, complex goal you would set for an agent to solve?